This is a question from rational number chapter of class 10 CBSE. Prove that root 3 is an irrational number. Okay, first of all, we must assume root 3 is equal to a by b, where a and b both co-prime. Co-prime means both the numbers a and b will have only one common factor, that is 1. Okay, let us squaring both sides. Root 3 whole square is equal to a by b whole square. We should write this beside squaring both sides. Squaring both sides. Okay. After squaring, what we are getting? We are getting 3 is equal to a square by b square. Now we must cross multiply this. 3b square is equal to a square. Okay. Now in an equation, what we know, if I can divide left hand side by 3, I must divide right hand side by 3 as well. So 3 is the common factor of this both side, as because it is an equation. Okay, so we can write 3 divides a square as 3 divides 3b square. Okay, we know that if a number is dividing square term, that number must divide a also. So a square is a square term. When a is capable of dividing a square, a must divides a as well. Like you can assume that 9 is a square term. If that is divisible by 3, square root of 9, that is 3, that is also divisible by 3. Okay, remind it. Okay, now let us assume again, let a is equal to 3k. Okay, for some integer k may be any integer, k may be 1, 2, 3, 4. So a is equal to 3k, what we have assumed. Now I am putting a is equal to 3k in the equation 3b square is equal to a square. Okay, what we can see? We can see if I place 3k in place of a, this becomes 3 square becomes 9 and k square. Now it is very clear, you can cancel this by 3. Both sides are cancelable by 3. I have cancelled both sides by 3. Okay, therefore we can say 3b square is divisible by 3, or 3 divides 3b square. B square is also divisible by 3. Okay, because 3k square is divisible by 3 as well. B square is also divisible by 3, because both sides are to be divided by same integer. Now b is also divisible by 3, whereas square term is divisible by a particular number, square root of that particular number is divisible by 3 also. So we can say 3 is a common factor. 3 is a common factor of A and B. But at the beginning, we have assumed that root 3 is equal to A by B, where A and B are co-prime. As because A and B are co-prime, they must have 1 as their common factor and no other common factor other than 1. But accordingly, we have come to a conclusion that root 3 is becoming a common factor of A and B. So, this contradicts the fact that A and B have no common factor other than 1. Therefore, the contradiction arises that root 3 is a rational. Primarily, we have assumed root 3 to be A by B because every rational number should be represented like A by B when A and B are co-prime to each other and B must not equal to 0. But what we have seen that 3 is another factor of A and B. So, other than 1, we have another factor 3. So, this is contradictory to our assumption that root 3 is a rational number. Hence, we can say root 3 is an irrational number. Okay.